So this is what we want to solve first. Now there's different ways we can solve it, because we could try graphing it to find the solutions, or different methods. But especially with, once we get variables where we have bigger than 2, the only method where we'd have something on the other side, or completing the square, is kind of out the door, because that really just works with squares. So the first thing we need to do with this is get it equal to 0. So we're going to subtract, come on, 48 from both sides. If we subtract 48x squared from both sides, we're going to get, apparently it is definitely on the pen, okay. 3x to the fourth minus 48x squared is equal to 0. Now again, I believe I said this yesterday, whenever we have or do not have a constant term, one of the zeros for this is going to be 0. Because we're trying to see what values of x will make this be 0. Well, all we have is variables in every single term spot, so 0 is going to show up. And the number of times it shows up is equal to the smallest degree attached to a variable. So since the smallest degree for this is 2, it means we'll have 0 twice. But another way we can see that is factoring out our greatest common factor between these two terms. 3 will go into 3 and 48, and we also have x squared. Because 3 is a factor of 3, and 48, if we add the two terms together, if we add the 48, 4 and 8 together in 48, we get 12. 12 is divisible by 3, so therefore they're both divisible by 3. So the 3 will factor out completely here. And if we factor an x squared out of x to the fourth, we're left with x squared. Minus, since we didn't factor a negative out, the signs will stay the same. 48 divided by 3 is 16. And that's it, because the x squared factors out completely. And again, when we factor stuff out, the smallest anything can get or factored out would be 1. If we factor it out completely, it will never be 0. Now we have two things multiplied together that equal 0, so one of them must be 0. So we have 3x squared is equal to 0, and x squared minus 16 is equal to 0. And again, as we've learned from Algebra 2, the degree is equal to the number of zeros that we will have from each equation. So 3x squared should have 2 zeros. X squared minus 16 should have 2. Now, 3x squared equals 0. Well, we've said, and normally we would divide both sides by 2 and go from there. Well, if we have more than one thing multiplied together equals 0, one of them must be. And is there any way I can make 3 be 0? No, it's already 3, yes? So the only thing that could be 0 in this side of the equation is our x squared. Yeah, our variable. So really we're just saying x squared is equal to, which we could square root both sides and say x is equal to plus or minus 0, really just x is equal to. And if we want to be particular about it, just 0, 0. It's got a multiplicity of 2. Now we can solve the other one, x squared minus 16. Now, because there's not a middle term, we can use the square root method, which is just saying we add 16 to both sides. Telling us x squared is equal to 16. Square root both sides, telling us x is equal to plus or minus 4. So our solutions are plus or minus 4, and 0. So the number of unique solutions that we have is 3, but the number of solutions we actually have is 4. And the reason that differs is because our multiplicity of 2 at 0 does not give us a unique solution, but we still have 4. Questions on any of those here? Now, I'm going to go on and graph it. 3x squared, not 3x squared. Clear all three of these out. Because we had 3x to the 4th minus 8x squared. Graph. As we see this here, 4 and negative 4, it crosses. Now at 0, it touches it but goes back down. And in Algebra 2, we covered, I believe we covered this, or hopefully they covered it for you, is that if it does not cross the x-axis, it touches it and goes back down, or touches it and goes back up, it never crosses it, it has what we call an even multiplicity for polynomial functions, which means the number of zeros at that location is an even number of times. So it could be 2, it could be 4, 6, 8, 10, going up. Now, it's not really talked about, but if it is crossing, where it crosses at 4 and negative 4, it technically has an odd multiplicity, which the smallest amount is 1. But it could technically have 3 or 5 or 7 or 9 solutions there. Now, for the most part, what we cover in trig and algebra 2, it's normally 1 is what it's normally set at, but it could be more. Even multiplicities normally stop at 2. We don't normally see most problems go beyond that, but we do have those cases that could occur. Does that make sense? Now, sinoidal functions, so sine functions, cosine functions, tangent functions, when we get into those, they do not have a multiplicity. I said that last year, but it turns out the properties of multiplicity don't work with those kind of functions. I did a little digging, not enough, but couldn't actually find an actual answer for why. And I actually asked the professor, and they didn't. It's just something that's not covered. There's probably a reason behind it, but neither one of us knew what it was. And my best guess, it might have something to do with surjective, bijective, or injective, surjective, and bijective, but that's above and beyond. You'll not have to cover it. So let's look at this one here. 9x to the 4th minus 12x cubed. What is 1, 0 that we know for sure? What's one value of x that will make this be 0? 0. And again, this is kind of a giveaway. There is no constant term. There's no number up here or no term without a variable. So 0 has to be 1. We actually know another one. Because what's the smallest degree? So how many zeros should we have? If it instead had been x squared as the smallest term, if it had been x cubed, we would have had. So it's kind of a giveaway for that there. Now, one of the biggest things, even though x squared is the greatest common factor between the two, we can't divide it out. Now, technically, because 3 is a common factor between these two, we can divide it out. Because I could divide everything by 3, which would give me 3x to the 4th minus 4x squared equals 0. We can do that. We can't divide out x squared. Because every variable we divide out of the function, we remove a solution. We remove a possible solution for this equation. Now for this one here, we're going to graph it and see what we get. And I'm going to graph both of these. So our starting equation was 9x to the 4th minus.
We would appreciate it. Thank you.
So we get this function here. So we can see our 2 zeros, and we see that it does cross either side. Now, I'm going to rewrite this because as we change it, we have now 3x to the 4th minus 4x squared. And let's see how the graph changes. The rest of the graph changed, but 4 main places, or well, 3. It didn't change. It still hits 0 and does not cross. And it crosses at the other 2. So that's the big thing is with this here, is that it changes everything. Dividing by 3 changes everything except where it crosses the x-axis, which is all we're focused on. We're focused on where it crosses the x-axis. So we can divide by what we call a scalar. We scale it down, but we're not changing the zeros. So we can, from here, do the same thing we did before. We can factor out in x squared, which tells me I have 3x squared minus 4 is equal to 0. Our zero product property tells us that x squared is equal to 0, and 3x squared minus 4 is equal to 0. We can do the square root method with x squared equals 0, or the fact that really x squared is just a short way of writing x times x. So I could either for both sides, so it's x is equal plus or minus 0, which is x is equal to 0, comma 0. We have 2 of them. Same thing. Here we can solve by first adding 4 to both sides, telling us 3x squared is equal to. Next thing we'll need to do is divide by 3. Telling us that x squared is equal to 4/3. And last but not least, we're going to square root both sides, telling us x squared is, or not x squared, x is equal to plus or minus. Now we do need to reduce this here. And the 30xs is the nicest one to do this with. Now there is a certain way we do have to type it in, because we can't just type in second square root 4/3. Because it's just going to give us this ugly decimal. So what we can do instead is say second square root of 4 over second square root of 3. I just break it up into its parts. And if we do this, it'll actually reduce it for us and leave it in a nice form. So our other solution is plus or minus 2 square roots of 3/3. And these are our solutions. Questions on any of this here? Now, before we keep going on, do we have a good understanding of how to type or a graph into the graphing calculator, how to get it to graph? We're good with that? Now, I did show you this last year. So this might be new for you, because what we can do with this, I'm going to clear one of them out, it really doesn't matter. We can have it actually find values for us with the graph. Now 0, I can go second table. When x is 0, y is 0. That tells us that for sure. But 2 square roots of 3/3, is that listed as an x value? Well, no, that's an ugly decimal as we saw already, yes? Now if we go second trace, second calculate, if you see the first one is value, I can hit enter. Now to get a fraction, we can do alpha y equals enter. It may, okay, it's just going to give us a division bar. That's fine. I'm going to put parentheses around the numerator to make sure it's dividing correctly. And say 2 second square root 3, because it gave me a parentheses to start the square root. I'm going to close it and close it again to close off the numerator. Divided by 3, because that's one of our solutions, yes? Enter. The y value is 0. We just checked it, and that checked out. So I can do second calculate value again and say negative 2 second square root 3 divided by 3. 0. So I didn't have to go through the whole process of typing it back in. I can just use the graphing calculator and let it do the work for me. But that's it. Questions on this here? We have this here. x cubed minus 3x squared minus 3x plus 9. I think it was, sure. Okay. And is the 3x positive or negative? Okay. So now we have the correct function up. X cubed minus 3x squared. Okay. Graph. Normally, this is where I want to try to go first. I mean, if I can graph it and get nice numbers, all the better, because it makes it easier to work with. And we see that it does cross at least one spot nicely. 3. So that tells us that out of the 3 solutions we can have, because it's a third degree polynomial, now one of them is x is equal to, the other 2 may or may not be nice solutions. Now, there's different ways to go about solving from here, but one of them is what most call factoring by grouping, which I think you've heard before. I will call it that in Algebra 2. I also call it greatest common factor squared or tripled, because that's all it is. We group it. Well, really the way that we group it really doesn't matter. I just try to group it in pairs or triplets where we have an even number and see what I can pull out of both. Now the first 2, x cubed and 3x squared, have a greatest common factor of just x squared. They don't have anything else. So if I take an x squared out of x cubed, I have x minus 3. Once we see one, it helps us with the other, because I know that for us to be able to continue this process, the other set of parentheses has to have x minus 3. They need something in common. So what does negative 3x and 9 have in common? 3. So we can factor the 3 out. But I need this positive 9 to go to negative 3. So taking the 3 out does decrease it from 9 to 3, but I also have to take out a negative. Because factoring out a negative 3 from negative 3x gives us positive x. Taking out a negative 3 from positive 9 gives us negative 3. So once we find one, we can use it to find the other. Now again, at this point, we do have x minus 3 in common with both. And we can factor it out. So I'm assuming most of this is not new. Kind of dusting things off, that's fine, yeah. That just means we don't need to go over more of them. Now at this point here, again, we have 2 things multiplied together equals 0, so one of them must be 0. As we've seen already, we already found that one. Here, the first thing we can do is add 3. So minus x squared is equal to, take the square root of both sides, plus or minus square root of 3. That's where our other 2 crosses come. We good with this so far? No questions? Okay, I just want to make sure. And I mean, we could do the same thing back with the calculator now, is say second calculate value, second square root 3 is indeed 0. So again, we can go second trace. The first one's value, negative second square root 3, and the other one is indeed 0. Now we could have tried finding second trace. The second one zeros, and whenever you find a 0, you put this little x first to the left of where it crosses the x-axis. So we put it down here, and we have a line. When it asks for right bound, we put it to the right of that value, and then hit it one more time, and we get this here. Now, if we knew for certain that negative 1.732051 x value is actually negative square root of 3, and we could change it over, then that works great. But if I was just given this value, my immediate response would not just be, oh, it's negative square root of 3. I'd have to go and try to figure it out. So sometimes this works well, other times it does not. Any questions over this here? Okay. So 6x cubed minus 27x squared minus 54x. Does anybody, do either one of y'all have a guess at what one of the values of x is? 0, yeah. One of the values of x is going to be 0. I'm going to try just graphing it. 6x cubed. Well, negative 27x squared, 54x. Second table. Well, one of the values is indeed 0, like we saw already. Another value is 6. Now we just need to figure out what the last value is, which is between negative 1 and 2, negative 2. And once we get it, then we're done. Now this one here, let's use this here, 0. So we go second, calculate 0. Now, again, when it says left bound, we want this little X marker, using the left and right arrows, to be left of the 0, where it crosses on the X-axis. So here, where it's below it, where we see we have, again, because we're going from negative to positive coming from left to right, we do have it to the left of it. So we'll hit enter. Now the next one it wants is the right bound. So now we need it above the X-axis. When we get it there, we'll hit enter. Now this third one's asking us to guess what we think it might be, but I don't want to guess. Hit enter again. So our third 0 is negative 1.5. Those are our 3 solutions. Okay. Now the big question is how did I know that that would work and not give us an ugly decimal? Probably. There's one main thing with imaginary solutions and irrational solutions. Our irrational solutions are like the last one, the square root of 3, the square root of 2, are ugly decimals. Now we could get some ugly decimals that are rational, but most of those, for the most part, are pretty standard. If we get 0.3 repeated, it's 1/3. If we get 0.1 repeated, it's 1/9. We can see some of those. But irrational numbers always come in pairs. So if one looks to be irrational, there's going to be another. So since we have 3 solutions, we know one of them 0 and the other 6. That leaves us with 1. So it has to be rational. So it kind of narrowed it down. Now what we could have also done is 1. Let's see here. Not divided by 6, because 6 does not work for all these, but 3 does, which would have given us 2x cubed minus 9x squared minus 124 is 8x. We get this here. Now we could factor an x out, which would give us 2x squared minus 9x minus 18. Zero product property tells us x is 0. The rest of this we could actually factor down. Third term's negative. Well, the only way we can get that is if the signs are and positive. They got to be opposite. Only way I can multiply two numbers and get a negative. 2x squared. Well, I'm going to just do this here. Actually, for time's sake, I'm going to flip the 2 and put it over here. Because really, when we're doing most factoring, I just throw them down and check at the end and see, and then adjust accordingly. And for time's sake, I know that the middle term has to be negative, so most likely the bigger number also has to be, yeah, the 2x has to attach to the plus so that it's multiplying with the negative. Now 18's 1 times 18, 2 times 9, 3 times 6. Now, out of all these factors, I know that the factor that goes with the 2x cannot be 18, 2, or 6 because they have a greatest common factor. And there's not one at this point that we have left. Out of all of them, I feel like, let's try 6 and 3. And again, I check it. X times 3 would be negative 6 times 2x is negative 12x. That does indeed give us our negative 9x. So these are our two factors. X minus 6 is 0, which is just telling us x is equal to, which we already know. 2x plus 3 minus 3 telling us that 2x equals negative 3. It's just negative 3/2 because we need the square root to get the plus or minus. But that does give us our 1, 2, 3. Yep. Exactly. I know that was a little quick. Questions on any of this here? Yeah, I'll wait. Probably looked down for a second, looked back up, and it was all solved. Yeah. What? That's an old meme that's been done time and time again. Do we have any questions on any of this here? Let's see here. We've got we'll do this one here in solving and then go from there. Yeah. I mean, solving radicals, it's not that there's overly complicated. There's this main set of rules or steps that we go through, and especially that I've kind of delved down into. One, okay, is to get the radical by itself is the first main thing I'd say. If more than one, even them out. If more than one, even them out. Okay, yeah. I do want that. Got it. Apparently I put those on the wrong page. Edit. Paste. Okay. If more than one, even them out. So if we had two, try to get one on either side. If we have 3, which we normally won't deal with, we'd have 2 on one, 1 on the other. If we had 4, 2 and 2. We try to keep them even. Now here, the next one does have 2, we'd have to even them out. Here, we just need to get this radical by itself. So the first thing we need to do is add x to both sides. Now, step 2 is to put both sides to the nth power. Put both sides to the nth power. And really the power that we're using is whatever's going to get rid of the radical. So we have a square root. So to simplify square root, we would use a 2. Because here the square root and square would cancel, leaving us with 2x plus 7 is equal to. Now the other side we have is x plus 2 squared. Now if it was just a number, we could go on squared and move on. But here we're really saying that we have x plus 2 times.
So it's x squared or x or x squared.
Almost. Because we would have x times x, which would be x squared. X times 2 is going to be 2x. 2 times x is 2x, and 2 times 2 is 4. And I think what you were trying to get at is that we would end up with x squared plus 4x plus 4. Step number 3 is not solve. That's step 4. Step 3 is if any radicals left, repeat steps 1 and 2. Essentially, we do it again. And we keep trying to repeat this process, even amount, put both sides of a power, even amount kind of deal, so that the radicals will eventually go away. The most that we'll do in here will mainly be doing it once or twice, because after that point, we should have them all gone, and then we can move on to step 4, which is solve and check. Because with radicals and rational equations, there are chances that we will have extraneous solutions. So at this point here, we do need to get it equal to 0. So we can minus 2x from both sides. Minus 7 is equal to x squared plus 2x plus 4. Minus 7 tells us that 0 is equal to x squared plus 2x minus 3. Any questions on any of this here? Now again, at this point, we can factor it, we could graph it, we can use the quadratic formula, completing the square. Any of these here, I don't know, let's just try squared plus 2x minus 3 graph. Does it cross at 2 nice points? Going to go second table. One of the values is -3 and the other is +1. Because we're trying to see what value of x will make the y value be. -3 and 1. So we did do half of step 4, we did solve it, but the last thing we need to do is check it. And the main thing we're checking is to make sure that we don't get a value of x that would be problematic. As we said, x is equal to -3, comma, 1. So we'll try -3 because there's a good chance it's going to cause the issues. 2 times -3 plus 7 minus -3 is equal to 2. 2 times -3 is -6 plus 7 minus -3 is +3 equals 2. -6 plus 7 is 1. Hey, we don't have a negative inside the radical, so that's good. Square root of 1 is 1 plus 3 equal to 2? No. So even though it didn't cause a problem inside the radical, it didn't work with our overall problem. We can do the same thing with 1. 2 times 1 plus 7 minus 1 equals 2. 2 times 1 is 2 plus 7 is 9 is 3, and 3 minus 1 is indeed 2, so our solution is, and that's it. Questions on this here? That's where we'll stop for today.